Hello. My name is Olivier Pegeon, so I am very glad to be there at Q2B. So to introduce myself, I'm a former IBM executive, which I left in 2021 to create QbitSoft early 2022. Even if I have an engineering degree in applied mathematics, I spent my whole career in sales and business, so I am a business guy. My goal today is to introduce you, to give you insights about use cases we are currently doing with some clients, real clients spending real money to understand if we can get value from Quantum. So first, I will describe what we are doing in QbitSoft, and then I will go through three use cases, which you will see that all of them in insurance. It was not a specific design for myself to show you insurance use case, but I got a lot of traction with those clients, so I have decided to show those projects. Obviously, we are working in other industries, for example, in logistics. So first of all, QbitSoft. So QbitSoft is a software startup, another one. And our goal is to work in the optimization area to help clients to continue optimizing, improving their operational efficiency. So regarding operational efficiency, I think you know the story. The simple things have been already optimized, and now the remaining value is locked into much more complex problems which are not easy to solve with classical IT, which is pushing organizations to use more and more AI to solve those problems, which can be very expensive and which can also consume lots of energy, which is becoming an issue for companies which have now other carbon footprint KPIs. So we do think at QbitSoft, I think you are sharing the view that quantum technology will help those complex problems. So the model of QbitSoft, the solution of QbitSoft is very simple. We aim to help clients to have an easy access to quantum solutions. And to do that, we have decided to put in place a software platform, and we have selected 6 mathematical optimization problems. You see it on the left, which are underlying problems in many use cases in industries you see on the right. So it's a software as a service model. The client will buy our mathematical algorithm to solve their business issues. We are providing the quantum capacities. We are buying the quantum capacities to power our algorithm and to power our platform. And you see there the first partner we are working with. And obviously, one of our objectives is to deliver value short term. So we are really focusing on the 6 modules you see there on quantum annealing solutions. So we have developed QBOs for those algorithms to run them on quantum annealers. First use case. So it's an insurance company with which we have signed a contract last year. This one has started last year, and it's a very pragmatical, use case, an automobile insurance pricing issue. In the client process, the insurance company is using a file, which name in French is véhiculier, which basically is a file which will classify all existing vehicles. I think it's 130,000 different vehicles, to classify them in risk class, so that each vehicle has a rating in terms of risk in this file. Currently, this file is produced by an AI, and the client is not satisfied with the way it is done. So he asked us, can you help us to pass current AI limitations? And obviously, we say yes. And so we are using to solve that one of the modules I just showed you, which is a quantum clustering module. And to design this module, we have used a specific approach, which is a K-medoid clustering approach. It's a very interesting approach because it will bring, by design, explainability, which was one of customer KPI in terms of value creation. It's a very interesting approach, but it is generating an NP-hard problem. It's the reason why it is not used today in classical reality, but it is not an issue for us using quantum technology. So where we are today, we have demonstrated that we have much more transparency and explainability, as I said, but it's by design with a medoid approach. We have demonstrated also that we have a great performance improvement because execution time is completely independent of the number of class, which is very interesting for our client. And we need now to demonstrate that we'll bring value in terms of quality. But for that, we need to go at scale using the real data set of the client, which, by the way, we will do next month, because we just signed another contract with this client to go at scale and to run the whole process with the whole vehicle data set to show the client that we will bring value not only in performance and explainability, but also in quality. And the plan of the client, he made it clear, if we have conclusive results, it will go into production by the end of this year, which is great. Second use case, another insurance. It's a different company, a big one, very interesting case also. It's a claim processing automation claim. The client is looking how we can improve the claim processing problem for weather-related claims, because this is more and more frequent for that client to get such problems. So to run that, we will analyze real-time satellite image to better understand, the flooded or fire area, and help the client to automate this claim processing approach. We are just starting this one. We signed the contract the months ago. We have some certainties about this approach, and we'll use one of the modules I just showed you on the first slide, which is a binary segmentation algorithm. And the fact that we will use quantum computers will help us to use graph-based segmentation approach, which is really interesting because it will help us to move from an supervised to unsupervised method, which will save time and bring much more efficiency. So we are very confident with this one. And on top of flooded and fire identification, this algorithm will be used also to improve the risk modelization, specifically for new type of risk. For example, the climate drought, which are creating cracks in the houses, which is a new type of risk the insurance are facing now with the climate change, which is costing a lot for insurance companies. So, and to do that, we will analyze the canopy of client parcels with this algorithm. And the third one, which is obviously a very important use case for insurance company, the fraud detection. As you may know, fraud detection is costing a lot for insurance company, not only for insurance company, by the way. And so the client is very interested to move forward with that use case. Very interesting to notice, this client is the same that who signed a contract with me for the pricing use case. Just interesting to see that having delivered some good results on the first use case, the client was very motivated to move fast to another use case. And we signed a new contract for this one. The principle of this use case is to be able to detect weaker signals, to detect frauds which were not previously detected with the current traditional AIs the client is using, and also to help to manage the alerts, because there is lots of alerts, which in many cases are false positive alerts, but which are generating lots of workload and costing a lot. And to do that, so we will use a third algorithm that I showed you on the first slide, which is a very innovative approach to use probabilist graphical models to achieve the goals I just described. I don't know if you know probabilist graphical models. Maybe have you heard about Bayesian network, which are kind of PGMs. Basically, it helps to encode probabilistic distribution on very large data set with a large amount of variables interacting with each other. And we'll develop a QUBO to make it happen on quantum annealer. And this approach, which is not feasible, very difficult to do it with traditional IT. With quantum, we will do two things. We'll calculate the structure of this graph with quantum, and we'll also calculate the parameter of this graph, parameter learning with quantum. And all in all, we'll be able to detect weaker signals because by design with this approach, we will be able to add expert knowledge and constraint and to establish classification rules for underrepresented populations that will help detect frauds which were not detected before. And also, second advantage of this approach is we will help a lot for the alerts to work on detecting if it's false positive or not by giving an improved visualization of the cause and effect relationship between the variables, which is by the essence of the graphical models. So a very, very promising use case. It will be a long shot because we started a couple of weeks ago, and it is probably a 1 to 2 year project. So, all in all, and as a conclusion, clients are very interested to understand if quantum can bring value. First, clients are ready to put money on the table to test it. And also, as you can see, there is innovative ways to try to deliver value short term on those use cases. Obviously, we have still lots of challenges in front of us, but maybe I will be there next year to show you the progress we have made with those cases. Thank you.
Thanks very much, Olivier. Just a reminder, if you have any questions, please send them in on the app. I actually had one. So, do insurance companies, in your experience, have the same explainability issues with machine learning that banks have in financial institutions?
Definitely, yes. And for the first one, the pricing use cases, it was a main, because we had a discussion with the client before selling, our clustering module. It was, what are your value creation KPIs? The first one was explainability. First one, even before the performance or the class stability. First one, explainability. It's, by the way, the reason why middleways are very powerful, because they are bringing explainability by design. So
Perfect.
yes.
Yes, thanks.